Welcome to the third video in this 10-part series on convective wildfires. My name is Tristan Rudolfs, and in this video we will discuss the formation of pyroclouds on top of wildfire-induced plumes. In general, we can distinguish between two types of pyroclouds, the pyrocumulonimbus and the pyrocumulus cloud. The main difference between those two is the maximum altitude that they can reach. Pyrocumulonimbus can grow up to 12 kilometers altitude, whereas pyrocumulus are typically reaching at maximum 3 to 5 kilometers altitude. Despite these differences, the main principle behind cloud formation in both cases is the same, which is the condensation of water vapor into liquid water droplets. Let's have a deeper look into the basics behind cloud formation. We can state that cloud formation generally occurs when the relative humidity exceeds 100%. So when we translate this to wildfire plumes, we can take the same approach as we did in the previous videos of taking a relatively buoyant air parcel that originates from above a wildfire. And we know from the previous videos that when this parcel rises upwards, it starts to cool. And the thing about cooling is that it means that the air parcel can hold less water vapor, which effectively means that the relative humidity increases. When we want this air parcel to result in cloud formation, it needs to be lifted high enough such that the relative humidity exceeds 100%. The altitude at which this happens is generally referred to as the lifting condensation level, which is the altitude or level to which an air parcel should be lifted to get condensation, so to get the relative humidity up to 100%. Let's see whether we can visualize this with the pictures from the pyrocumulus and pyrocumulonimbus that I showed before. When we look at these pictures, we visually see the transition from a dry plume where there is no condensation yet towards the cloud. And this transition is the point where the relative humidity goes from below 100% towards above 100%, meaning that clouds can form. And this is what the lifting condensation level means in reality. It's the height that the plume has to reach before clouds can form. So to summarize, we have seen that pyroclouds can form when a plume reaches the lifting condensation level. And this means that combined with the previous videos, we now have all key ingredients to predict future plumes. We know that with buoyancy, we can explain the rising motions inside convective plumes. We understand the different atmospheric conditions in which plumes can develop. And we know when clouds can form on top of plumes. So in the coming videos, Brian Verhoeven will take you along on how to predict convective plumes using weather predictions. Thank you very much for watching, and I hope to see you in the next videos.